Okay, here we are. Big data applications and analytics. Jeffrey Fox, your instructor in the data science curriculum of Indiana University. And we're now doing the Internet of Things and Sensors section and unit. And we're going on to the Industrial Internet of Things, a pretty interesting concept which has been pioneered by General Electric. So, this is the first lesson on the Industrial Internet of Things, IoT. Here we are. And we summarize sort of a general introduction to that and a survey and expectation from industry. It comes from an analysis done by Accenture. Okay. So I like all these terms: intelligent machines, brilliant machines, software-defined machines. So these are sort of trying to capture in a short jarring phrase what's meant by the industrial Internet of Things. That it really consists of a whole set of software controlled and software emitting, messaging emitting, data emitting devices, which of course could be making things or running things. They could be engines or robots or what have you. And they're basically tomorrow's industry. And General Electric, for example, uses them in jet engines, in their transportation work, oil and gas, and healthcare. Those are just areas where GE has a major emphasis. And we actually pointed out right in the motivation section of this course that GE claims its engines give more data than Twitter in a given time period. And here is a nice gesoftware.com is a good source of information about the industrial Internet of Things. They've developed software which is not, at least I don't actually know so much about it, except it's got a good name, predicts, presumably because it predicts things. And they have a software division that has grown now to 700 people in 3 years. So that's reasonably impressive. And of course, they placed it next to the center of the world in Silicon Valley. Shows that the rich get richer, do they not? And I meant here the rich being the Silicon Valley community, which is the source of the internet revolution, with the old areas like North Carolina, Texas, Austin, and Boston quite a long way behind in this area, although they have, of course, very competitive academic research activities. So for GE, there's identification of jet engine faults, managing traffic are examples of the applications. They also have nifty examples in railroad managing, which is part of their transportation efforts. So they think of the challenge as being taking the world's population, 7 billion people, 50 billion things, and merging them all together as we merge the consumer and industrial internet. So that's their grand challenge. And it involves physics, because you're predicting in transportation, predicting where things will go. Obviously, you need to understand, if you're applying them in health, you have to understand medicine. You need to automate the information flow. That's what Apache Storm and Kafka are doing. You need to make predictions from the analytics, and you need all the standard tools like HBase and Hadoop and things. So it has old data it's accessing from databases, has new real-time data, and the analytics are going to depend on the industry. You're going to do different things for transportation than you do for health. And it's obviously got an investment here is likely to have huge impact across all industries. And the industries that adopt the industrial Internet of Things is likely to be the ones where your investment in their stocks is going to pay you off. So you better find out who's doing it. So we now have a sort of subset of the industrial Internet of Things, or maybe it's an associated to that, which is the enterprise Internet of Things. And that just basically is those things which are integrated with enterprises. So this includes, for instance, office buildings or factories and drone delivery systems, and for the education enterprise, classrooms, and for the dining exercise enterprise, restaurants, which are feeding back in real time comments from customers and on the food and on the waiters and things like that. So you can, you're meant to be you need to look at your enterprise. Say, I have over there a vacuum cleaner. We will add a thing to that vacuum cleaner so it becomes a brilliant vacuum cleaner or a software-defined vacuum cleaner. So we need to we need to take these inexpensive sensors, which are down to less than $1 each, and manage the lighting, the air conditioning, the energy, the security, our inventory, and everything else that we need to manage, and connect them all via these devices into my enterprise network. And here's a nifty picture from Cisco showing this happening in an office building. And this is just where we get the lighting, the heating units, the fire control system, the air quality, air handling. These are all intrusion, surveillance, the reader of who enters the building and everything is all integrated together so that you will know who's in there, why, how long they're in there, where they're using energy and water, and when they're buying a Coke or a 3M, M&M candy and what have you. So that's the enterprise Internet of Things. So here's this survey by Accenture, which is aiming to try to quantify the industrial internet and the industrial Internet of Things. And, there are lots of big numbers here, including 15 trillion global GDP by 2030. And whether it's 15 trillion or 1 trillion will partly depend on how we do in these modern developments. But the opportunities are in many areas. Aviation, obviously, we know from unfortunate recent crashes that one of the troubles with those crashes is those aircraft were not actually feeding much data back, at least, and that data wasn't even being looked at. So there's some problems there. But it appears that you could have actually had the cloud monitoring the behavior of these aircraft and alerting far more quickly and precisely what's gone wrong. And that seems actually rather trivial to do, in my opinion. Oil and gas, not only need to develop new oil wells and things like that, we need to make them intelligent, so we know how to manage them and their distribution of what they drill. Transportation, well, that's all types of transportation, from trains to buses, cars, etc. Aircraft, they all need to be automated with Internet of Things. Power generation, there's a smart grid, that's power distribution, really. Any manufacturing, we saw, we know robots are used in manufacturing. Healthcare has lots of applications that we'll study individually. And of course, the mining materials is also likely to do better with monitors telling you what's happening. And this analysis pointed out that not all big data is equal. Maybe Twitter is the most famous big data, and because they are giving it away and making it easy to use. However, it may not be as valuable to look at rather silly tweets from people as opposed to the jet engine squeaking away, telling you it's made a problem, or the aircraft is nearing a stall speed and what have you. And the claim is there's more business value on a size-adjusted basis, namely business value per sensor, than in other type of business value per byte of data in industrial internet than the consumer internet. So they did a survey which has covered healthcare, which we'll look at separately, and the other industry, and they looked at the industrial internet and what the industry executives thought about it. And the response is not terribly surprising. These surveys are always biased. We come in with a survey saying, we're surveying how innovative your company is. And then question number one, is your company innovative on using Internet of Things? You say, of course I'm really innovative. Yes. So it's rather, actually, it requires some challenge to actually say, no, I think Internet of Things sucks. It's a stupid waste of money. We're deliberately not investing in that area. That's not, few people have the ability to make such statements. But obviously, security is a serious problem. We had the what's it called, Stuxnet, as an example of what happens with machines which have viruses get into them. We have the usual NIH syndrome, and everybody does their own thing, and it's very difficult to integrate. But to actually get the right answer, remember that picture of the office building? We need to integrate the elevators with the access control monitors and things like that, so we understand much more clearly what's going on. But that's not so easy if your elevator comes with a built-in Internet of Things system, which is incompatible with the Internet of Things system with your lighting and so on. So this has some urgency, and here is the link for this Accenture study. So in the study, they have anecdotes. I assume the survey had the opportunity for people to actually add value. So it's pointed out that at least over the last 50 years, railroads did automation, but now everything that can be automated is automated, and now they need to make the automation intelligent by linking the automated systems with all their sensors and put more sensors and make good decisions. And one thing you can, here's one, actually, let's jump to this bullet here, which is sort of related, of unplanned downtime. For instance, airlines lose $45 million a day from unplanned delays. And so making better use of the industrial Internet of Things allows you to reduce the downtime and do better planning to rescue yourself from downtime. So Johnson Controls is a leader in the industrial Internet of Things because they build control systems. And actually, I should note that sensors and the whole theory of sensors and the use of sensors and the Internet of Things is closely connected with this engineering field called control systems, because these Internets of Things are all meant to be fed into each other, and that's called control. So actually, you can learn a lot from control theory, and control theory can learn a lot from the Internet of Things. And Johnson Controls is just one of the examples of the companies that really is a pioneer there. In fact, if it's not going to be a company in that area unless it is a pioneer in this area, because it's the future of their field. So here is a survey which here's the first question: what are the proportion is this is actually in big data analytics, not particularly in IIoT, but the claim is for these industrial Internet of Things. Big data analytics is closely focused on IIoT. So here we have 51% of the responses say that 21 to 30% of their technology expenditures in big data, and 22% of people actually are bigger than that, and only 27% are less than that. And here's a tiny number: 3% of the respondents have less than 10% of their expenditures in big data, their technology expenditures. And then the question, is it going to be decreasing? Answer is 0. Stay the same. Modest 24%. Increase 76%. Onward. Here we look at this by industry. So we have orange is top. Green says big data analytics on the top 3 priorities. Purple, the top 5, and blue is really not interesting. So Here we have these, well, you could sum the green and the orange, and we can see that power generation is the largest. It's third because it's actually top priority only in 31% of the time. But within the top three is a huge number. So it's 94% if you sum these two categories. So then we have aviation and wind is similar. Wind a tiny bit irrelevant fraction bigger. Notice wind does have a few people who think it's irrelevant. Power distribution, pretty conservative industry, but even that industry, only 84% within the top three or top. Oil and gas, 3%, no way, Jose. 9% within the top five and below the top three, so numbers 4 or 5, and here you have. So you basically have the only one, maybe mining is the most least impacted by big data, but even that's pretty impacted. 79% within the top three. So in the last slide of this set, we have this question about in the manufacturing area and actually other areas, telecom, what are the early adopters? And we find industrial machinery as top with 18%, automotive, the connected car, consumer and industrial electronics, aerospace, 15%, and of course, consumer packaged goods, groceries and things are sort of behind, when metals and mining also behind. Healthcare is below the top, it's sort of hanging in there. So this is this survey, which is of course, like as I noted, like all surveys, biased, adds weight to the statement that the industrial Internet of Things and big data is very important for industry. So that's the end of this section on IoT and sensors. Thank you very much. This is Geoffrey Fox ending this lesson. Thank you. All right, it's Geoffrey here again. What color should we use? Orange. Big data and applications is the course. Or X-Informatics is the old name, which has fallen into disuse. And we're doing the Internet of Things and Sensors, unit and section. And we're doing a second lesson on the Industrial Internet of Things. And here I am, and off we go. So we're on lesson 4 in this unit, and we're doing some examples from General Electric, who are a real pioneer in this area. I'm really impressed by their effort in the Internet of Things. So these are just examples from their GE software stack. Remember, they have this software division in Silicon Valley with 700 people, grown in the last 3 years. And here is just illustrating one particular part of their work: wind farms, all these rotating vanes. And you have here control systems, which is this, and analytics, deciding what the optimal speed to rotate given the wind and things like that, and what the power demands and the ease of storing it and things. Here's our control room here, but presumably most of this is computer controlled. So we have here they show various sensors on the engine and on the vanes, presumably. And this is just one example of the IIoT applied to power generation. Here is a more general example of the old style way that things were done in the engine world. Then you have engines which break, and then you have costs because your machines break. And you have servers which are sitting in all over the place, and the servers have the wrong software in them, and the machines have the wrong software in them, And then you have networks that are rather flaky, and you find you can't deploy your nifty new software and things like that. So that's yesterday's half-hearted attempt at automation. And here we have the new thing with everything fully interconnected in a reliable fashion, presumably wireless networking, clouds, and a robust environment. Maybe on sort of what you might call local proxies to do the computations that need to be done in a time-sensitive fashion. We have, just as we have this application ecosystem for smartphones, we have an application ecosystem for machines, and every machine can download its version of Minecraft and build itself a simulation of itself or something like that. And when they get and then they, I don't know whether machines will unfortunately become so intelligent. They will want other more frivolous applications, but at least they'll be able to download the applications to monitor their health and tell them what to do better to survive longer with less fuel. There's a very pretty site at this Rail Connect 360 URL where you can press buttons and all sorts of nifty things happen. Here is some sort of rail transportation center, and these trains here all move around. And if you press these knobs, you get various informations from sensors. And well, very nicely done site. I'm not quite certain it just looks pretty. I'm not quite certain actually you gain an awful lot of information from this site, except I'm impressed that they would put so much effort into it. All right, here we have an example of one of the things you can do. Here you can actually make the trains move, and then you can put up little big nets that you can save $2.5 billion a year in crew, fuel, and asset costs by doing a better velocity optimization. And that comes from here. You see here you have these tabs here. You can look at the various fuel efficiency tab and things like that. So this is the final slide of this set with this really nice idea of a software-defined machine. Of course, I like that because we have software-defined networks, software-defined computer systems. Here we have software-defined machines. And they involve the linkage of the clouds to the machine. Some of the software's on the machine, some of the software's on the cloud, and the whole application links them together. That's the challenge. To link clouds to machines, machines to machines, that's orchestration or systems. So just as you have computer systems built using, OpenStack Heat. So I don't know, we're not going to run fully OpenStack on every one of our machines, but we might run, Docker on every one of our machines, the equivalent of Docker. And then we would then link all these things together with the equivalent of Apache Crunch to integrate them together to produce this wonderful software-defined machine, which was going to do whatever we wanted to do with less cost in some optimal fashion that also runs in a more conservative way that makes all the machines last longer. So that's it. Software-defined machines and software-defined railroads and software-defined wind farms. That's what we've seen in this lesson. It's a pretty interesting future. Thank you very much.